Hello everyone, today I would like to show you how you can generate PWM waves from the PWM pins of an Arduino. As far as we know that there are certain dedicated pins like pin number 10, pin number 11, pin number 9, pin number 6, pin number 5 and pin number 3 available in Arduino which has the capability to generate a pulse width modulated wave from it. Fine. So for that I have on the screen you can see that we have oscilloscope connected to pin number 9 of Arduino. So we'll try to generate a pulse width modulated wave at pin number 9. So we program the Arduino accordingly. So since pin 9 we are using this as output, so we declare the pin number 9 as output, okay, and we'll send certain analog value to that pin number 9. So right now I'm sending 50 and we'll observe what kind of a wave we are going to get in the Arduino. So as I run this program, okay, I can see that on our oscilloscope we get this kind of a wave, right? So the part, okay, which is rising part, okay, this part is known as on time in PWM signal, and the falling range, okay, that goes at a zero axis is known as the off time period. Okay, so we are getting a small amount of on time when we send signal 50 to it. Okay, so let us increase that 50 to 100. So when I give 100 as the output, as the analog value to the pin number 9, okay, we should get a signal wave which has a more on time period as compared to the previous one. So here we can see we have increased the on time period. Right. Similarly, if we increase the signal, available value that we are feeding to pin number 9 to say let's say 200. Okay, now we are supplying analog value of 200 to pin number 9. So this will again increase our pulse width of the pulse at the output. So here now we can observe that our on time is more than the off time. Right. So similarly, you can also reduce the on time period by sending small amount of analog signal to pin number 9. Say right now I'm sending it as 20, okay, and we'll observe the output waveform. Okay, here we can see we get a very small on time period and off time is more. So this way variable PWM wave can be achieved at pin number 9 or the other PWM pins of the Arduino, right? And these values, okay, or this PWM wave is mainly used to control the speed of a DC motor that we'll see on later section. Okay, fine. And as of now, we are making changes in the program in order to get the various values, okay, like 50, 10, 100. So if we could attach some sensor at the output, like potentiometer, from where we can achieve directly those values, or by moving those potentiometer, we can change the width of the pulse, and that's going to be very useful for our upcoming experiment. Fine. So for that, we'll add a potentiometer at the input side of the potential or the Arduino. So let's see that. Okay, so here you can see that I have connected a potentiometer to the analog pin of Arduino, that is A1. Okay, and now since we have added a sensor or a potentiometer to the Arduino, now we need to reprogram it. Okay, so for that what we'll do is we'll declare an input pin. So pin mode, okay, pin mode E1 as our input, okay, at the programming part. And what we are going to do is we will try to read this pin. So for that we'll initialize a value integer a. Okay, we'll read the input pin. Since it is an analog sensor, so we'll write analog read. Okay, analog read A1. Since we have connected the pin to A1 pin of Arduino, a potentiometer to A1 of pin of the Arduino. So we are reading those pins, and whatever the value at A1, we'll directly send that to pin number 9 in order to control those width of the pulse using a potentiometer. So once the program we have compiled, we'll just go to the circuit. Now here what we'll do is we'll just move the potentiometer. See, as we move the potentiometer, now our width of the pulse is being varied. Okay, as we increase this value, the width on time has been increasing. So at certain point you'll notice that we won't get any output wave. Okay, this is because the analog pins of the Arduino are 10 bits, but the output pin is only of 8 bits. So the maximum value that we can feed to the output pins of the Arduino are 255. Okay, uh, and the input pin that we are using here is of 10 bits. Okay, so what we are doing is we are directly sending the value of 10 bits to 8-bit pins. Okay, so once till 255 the pin will take, okay, like 2 to the power 8 is 255, 256. But when we cross 256 value, the value at pin number 9 will overflow. So for that, what we'll do is we'll just convert, okay, from 10 bit to 8 bit, just before sending the value to pin number 9. So for that, what we'll do is the value that we are sending, okay, we'll just divide this by 4. Okay, so because the 10-bit value, maximum 10-bit value is 1024. If we divide that by 4, we'll get 256. Okay, so once we divide the value that whatever we are getting at A1 by 4, fine, so that will convert a 10-bit to 8-bit. Okay, and now what we can visualize is that, okay, from this point to this point, we are going to get the whole of the PWM pins, right? PWM wave. So you can observe this in the video here, right? So now we can able to move the potentiometer from top to bottom, from 0 volts to 5 volts. Will achieve certain kind of a wave at the output of the PWM pins, right? So now this PWM pin can be used to control the speed of the DC motor that we'll see in our next video. I hope you understood till this point. Right? Thank you for listening.